To perform off-rate experiments, you must first form loops and allow them to equilibrate. This can be done by following the steps in the on-rate experiment, with the exception of the quenching steps. Simply mix equal volumes of 160 picomolar construct and 6 nanomolar streptavidin. Allow this to form loops for 10 minutes. To perform the off-rate experiments, samples of the loops will be allowed to sit in quenching conditions for different amounts of time, with the idea being that if a loop opens, it will do so irreversibly, as the now available binding site will quickly be quenched by the large excess of free-floating biotin in solution. To avoid having to run many gels, it is easiest to do the longest time point first, so that all of the samples can be run on the same gel. For example, if you wanted your longest time point to be 72 hours, you would mix 10 microliters of loops with 2 microliters of saturated biotin 72 hours before you planned on running your gel. An example time series for the biotin streptavidin system would be to take time points over 5 days at room temperature, in the presence of 200 millimolar salt. Alternatively, for a quicker experiment, time points can be taken over 3 hours at 50 degrees C and 200 millimolar salt. To form the loops, follow the protocols in the previous videos to generate linear DNA, hybridize on the functionalized and unfunctionalized oligos, dilute the construct, and dilute the streptavidin. Note that if you wish to do the off-rate experiment under different solution conditions, all you need to do is alter the buffer in which you dilute your streptavidin and your construct. If you wish to do the off-rate at a different temperature, you simply need to let the samples sit in a water bath or a thermocycler set to the desired temperature, rather than at room temperature. See online methods, Halverson et al. 2011 and Kusa et al. 2014 for information on how to implement the Nanoswitch platform for non-biotin streptavidin systems. Once you have the required materials, you may proceed to do an off-rate experiment. The following protocol illustrates an off-rate with the following time points in minutes: 0, 1, 5, 10, 15, 30, 45, 60, 90, 120, and 180 minutes. These times do not need to be adhered to strictly, but this range of times is good to show a significant off-rate at 50 degrees C. To form loops, add 70 microliters of the 160 picomolar construct to a new protein low-bind tube. Add 70 microliters of the 60 nanomolar streptavidin to 70 microliters of DNA. Allow this to sit at 25 degrees C for 10 minutes to allow loop formation to go to completion. 180 minutes before running the gel, mix 10 microliters of loop mixture with 2 microliters of saturated biotin. Allow this to sit at 50 degrees C in a thermocycler or water bath. Repeat this for the remaining time points. 1 minute before running the gel, mix 10 microliters of the loop mixture with 2 microliters of saturated biotin. Allow this to sit at 50 degrees C in a thermocycler or water bath. 10 microliters of an unquenched sample, held at the same temperature, can be used as your 0 point. Cooling your samples to 4C will greatly slow the off-rate and give you more time to prepare and load your samples. To each of your samples, add 2 microliters of 6x-Ficol loading dye. Do this right before loading and running the gel. Some of the liquid may have condensed on the cap. Mild centrifugation can help ensure that all of your volumes are the same. Finally, load, run, stain, and image the gel as described in the previous video, or in section 5 of the written protocol. Thank you for watching this video. I hope it was helpful in getting you started in using DNA nanoswitches in your lab. If you have any questions, please feel free to reach out to us, and we'd be happy to help.